Hello, this is Mrs. Ward. Now I'm going to go over the second half of the first review worksheet for the final exam. So this one is asking you to find the limit as x approaches 2. Notice that there is no direction, so it's just as x approaches 2. So in order for the limit to exist, it has to be approaching the same number from both sides. So minimum points is to make a table. You should be able to do direct substitution. If I put in 2, I'm going to get 0 over 0, which is my clue that that means that something will simplify. So I'm going to try and factor. So I'm going to rewrite this as a limit as x approaches 2. Here's that negative sign. Then I'm going to have x minus 2. And then the denominator will factor as x minus 2, x plus 1. Then the x minus 2's will simplify. So I'm going to still find the limit as x approaches 2 of negative 1 over x plus 1. Now it's okay for me to substitute into 2. Before I couldn't because it would make the denominator equal to 0. So the limit as x approaches 2 is going to be negative 1 over 2 plus 1, which will end up being negative 1/3, and that is going to be my final answer. Moving on to the next one. Again, if I do direct substitution, I'm going to have 0 over 0, which tells me that I can simplify. So as x approaches 2, there's that negative sign, x minus 2. The denominator factors is x plus 2, x minus 2. That simplifies. Now it's okay for me to put 2 in this. So I'm going to say the limit as x approaches 2 is going to be negative 1 over 2 plus 2. So my final answer is going to be a negative 1/4. Moving on to the next one, again, if I put 0 in, I'm going to have 0 over 0. So it's not, I can't factor, but what I can do is I can simplify this. I'm going to multiply the first fraction by 4 over 4, multiply the second fraction by 4 plus x over 4 plus x to give those a common denominator. When I do that, I'm going to have 4 minus, and then I'm distributing this negative sign through this whole thing. So this will be minus 4 minus x all over 4 times 4 plus x. And this whole thing is over x. Here the 4's will equal 0. So I'm left with negative x over 4 times 4 plus x. And now I'm going to multiply by the reciprocal of this, which is 1 over x. Now the x's will simplify. And now that I've gotten rid of that x factor in my denominator, it's okay for me to substitute 0 in. So I'm going to have negative 1 over 4 times 4 plus 0. And I'm going to get a negative 1/16. So I'm going to want these fractions. I'm not going to want the decimals. That tells me that you're doing the work. And I'm going to want to see all the work. Okay, the next one, I'm finding the limit as x approaches 2. Again, I'd get 0 over 0. This one has a square root, which means I'm going to multiply by the conjugate. So plus 4, I'm going to multiply both the numerator and the denominator by that. And when I do that, I'm still taking the limit as x approaches 2. And when I do that, this times this will just be x plus 14. And then the 4 times the 4 will be minus 16 all over x minus 2 times the quantity of x plus 14 plus 4. Still can't substitute in 2 because it's going to make this denominator equal to 0. Here, when I combine like terms, I'm going to have x minus 2 over x minus 2 times this. Now the x minus 2's will simplify. Now it's okay for me to substitute 2 in. So I'm going to have 1 over the square root of 2 plus 14 plus 4. Well, the square root of 2 plus 14 now would be the square root of 16, which is 4. So I'm going to end up with 1 over 4 plus 4, which will end up being 1/8, which is my final answer. Okay, the next one, it says, for each function, identify the holes in the limit behavior at all vertical asymptotes. So I know it's discontinuous at x is equal to positive 2. And then when I look at this, I know that I can't simplify that it's going to stay there. So that means I'm going to have a vertical asymptote at, and remember, it has to be in the equation of line, x is equal to 2. So I've identified the hole. I have no holes. I only have one vertical asymptote. And now it wants me to describe the limit behavior for all vertical asymptotes. So at this point, you're probably going to pick up your calculator and graph it. Here you're approaching 2, so here's your vertical asymptote. So I'm going to say the limit of f of x, because I don't feel like writing that whole thing again, as x approaches 2 from the So as I approach 2 from the left, because I read from left to right, as I'm approaching from the left, the limit appears to be going to negative infinity. The limit of f of x as x approaches 2 from the right, which means I'm coming from this direction, it's going to go to positive infinity. So that's how I'm going to do that one. The next one, again, I am going to look at this. I look in the denominator and I can factor that as x times x plus 2. So I am going to have discontinuities at x is equal to 0 and at x is equal to negative 2. Now to check and see what type of discontinuities those are, I am going to see if I can factor that numerator to see if I can simplify any of them. And when I do, I can factor out a 2. I'm probably going to factor out a negative 2. I hate that lead coefficient being negative. Negative 2 times x squared minus x minus 6. So that's going to factor as x minus 3, x plus 2. So I can rewrite this as negative 2 times x minus 3, x plus 2, and that's over my denominator, which is x over x plus 2. These simplify, which means I'm going to have a whole at x is equal to negative 2, which means there's a removable discontinuity. My non-removable discontinuity is going to be when x is equal to 0. So I'm going to have a vertical asymptote at x is equal to 0. To talk about the limit or the end behavior as I approach that asymptote. So here's my graph. Here's that vertical asymptote. Notice I do not have a vertical asymptote at 2 or at negative 2. I can't even tell that it's not continuous. I'd have to actually go on my graph to see it, or go on my table to see it. So as I'm finding the limit of f of x as x approaches 0 from the left, that's going to be negative infinity. And then my limit of f of x as x approaches 0 from the right, again coming from the right, that's going to be positive infinity. And that's how I'm going to discuss my end behavior for those two. Next one, I want to evaluate each limit. So this one's the limit as x approaches 4, and it tells me it's a step function. Remember the graph and step function, we're doing the int for greatest integer. And that's what those brackets mean. I'm going to 4, 1, 2, 3, 4. So there's 4. So if it gives me something like this where I'm approaching x from 4, if I'm taking this limit of f of x as x approaches 4 from the left, 4 from the left, that looks like it's going to be 3. And if I take the limit of f of x as x approaches 4 from the right, coming this way, that looks like it's going to be 4. Since they are not the same number, I'm going to say that this limit altogether, the limit of f of x as x approaches 4 without a direction, does not exist because it does not approach the same number. The next one is a piecewise function. So in order for that limit to exist at -5, because -5 is where I have that break, they have to be equal to the same number. So I'm going to put a -5 to the first part. So I'm going to have an opposite of -5 minus 2, and that's going to be 3. Then I'm going to do, so that would be the limit of, so if I want to find the limit of f of x as x approaches -5, and again, this is when x is less than or equal to, so this is from the left, that is going to be 3. When I put -5 into this equation, -5 plus 8, and I also get 3, that means the limit of f of x as x approaches -5 from the right, because this is when x is greater than -5, is also going to be 3. Since these two are the same, the limit of f of x as x approaches -5 without a direction, the limit of the entire thing will be that number 3. And that's because they equal the same number. All right, hold on a second. Somebody's knocking. Okay, and these ones are asking you to find the derivative with respect to x, but they're asking you to use a definition, which is that limit of f of x, the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Okay, so to do this, I'm going to say the limit as delta x approaches 0. I'm going to have 1 over x plus delta x plus 5 minus 1 over x plus 5, and this is all over delta x. Have to have a common denominator in order to add these two fractions, and I'm going to want to add these two fractions to simplify. So I'm going to multiply this by x plus 5, this by x plus 5, this by x plus delta x plus 5, x plus. And when I do that, I am going to have x plus 5, and then I'm distributing this negative sign, so this will be minus x minus delta x minus 5, and this is all over, and dear heavens, I'm not going to even try and multiply this out, x plus 5, x plus delta x plus 5, and then this is understood to be over 1, so I'm going to multiply by the reciprocal, so 1 over delta x. Then what I'm going to notice is that the x's will equal 0, the 5's will equal 0, and so now I have negative delta x and this positive delta x, and those will simplify. So I'm going to end up with a limit as delta x approaches 0 of -1 over, and now it's okay that I put in 0 for delta x because it's not going to make my denominator equal 0. So this will be x plus 0 plus 5. And then when I simplify that, my derivative, because now I can stop writing that, so my derivative, I'm trying to see what I started off y, is going to equal -1, and then this will just be x plus 5, and I have 2 of them, so it'll be x plus 5 squared. And it should be very easy for you to check these now because you know how to find the derivative using them multiple ways. Okay, number 34, doing the same thing. So I am going to switch colors because I'm going to run into myself here. Okay, so I'm going to do the limit as delta x approaches 0, and I'm going to do the square root of 4 times x plus delta x plus 1 minus f of x, which is 4x plus 1, and this is all over delta x. So I have that thing where I have radicals, which means I'm going to multiply by the conjugate. So when I multiply by the conjugate, I am going to multiply by the square root of 4 times x plus delta x plus 1 plus the square root of 4x plus 1. So when I do that, I'm going to end up with the limit as delta x approaches 0, and then when I multiply this times this, I'm going to have 4, can I write 4x plus 4 delta x plus 1 minus 4x minus 1 when I distribute that negative sign, because that times that, all over delta x. So the limit as delta x approaches 0, the 4x is equal to 0, 1 is equal to 0, and I'm left with 4 delta x over, oh, I made a big boo-boo, but I'm going to catch it, and I'm not going to edit. This is a great learning moment. If I multiply my numerator by that, I got to multiply my denominator by something, so I'm going to multiply my denominator by the square root of that 4x plus delta x plus 1 plus the square root of 4x plus 1. So I'm multiplying my denominator by that. So here, let me squeeze this out of the way and write that again. So I'm writing this 4x. You can't stop me. I just think it's a lot to see. So square root of 4x plus 4 delta x plus 1 plus square root of 4x plus 1, and this is all times delta x. Okay, feels so much better now. And then I'm going to write that yet again. And this is times that delta x. Now the delta x is simplify. And now it's okay for me to substitute in 0. So I'm going to still write limit as delta x approaches 0. I'm going to have 4 over, and then this will be the square root of 4x plus that will be 0, right? 0 plus 1 times the square root of 4x plus 1. So I'm going to end up with my derivative equaling 4 over the square root of 4x plus 1 squared, which if I take the square root of something squared, oh no, that's a plus sign, Mrs. Ward. That's a plus sign. No squared. No squared. Oh my. No squared. I'm going to have 2 of them. So I'm going to write a 2 there. I'm going to have 2 of them. Now the 4 and the 2 will simplify, and my derivative will end up being 2 over the square root of 4x plus 1. And that's my final answer. And that's it. That is it. All right, we're good to go. See you next time in class. Hope this helps.